Welcome to the lesson on hydroelectric energy. In this lesson, we will provide you with an overview of hydroelectric energy, including its origins, how it is generated, the different systems used, and the pros and cons of this renewable energy source. Let us look at our lesson objectives. By the end of this lesson, you will be able to describe hydroelectric energy. Next, you will be able to explain how hydroelectric energy works. Subsequently, you will be able to name and describe the different types of hydroelectric power processes. Later, you will be able to name and describe the different types of hydroelectric dam processes. Then, you will be able to list the pros and cons of hydroelectric energy. Finally, you will be able to explain how hydroelectric energy influences BEV manufacturing. What is hydroelectric energy? Hydroelectric energy is electricity generated by harnessing the power of flowing water through turbines in dams or rivers. Hydroelectric plants use dams to store water and then release it through turbines to generate electricity. Hydroelectric energy is a clean and reliable energy source that can provide significant electricity to the grid. Let's look at the historical context of hydroelectric energy. Water wheels have been used to power machines such as grain mills and sawmills for thousands of years. The earliest known water wheels were developed in Mesopotamia around 3000 BC. The first hydroelectric power plant in the U.S. was built in Appleton, Wisconsin in 1882. This plant was relatively small but paved the way for developing more extensive and efficient hydroelectric plants. The construction of large-scale dams and reservoirs for hydroelectric production became more prevalent in the 20th century. These dams and reservoirs allowed for the storage of large amounts of water, which could then be used to generate electricity during periods of peak demand. So, how does hydroelectric power work? Flowing water creates energy that can be captured and turned into electricity. This process is called hydroelectric power. Hydroelectric power plants have been a significant source of electricity for over a century. Most modern hydroelectric power plants use dams to control water flow and channel it through turbines, which generate electricity. By harnessing water flow, hydroelectric plants are considered a more environmentally friendly alternative to traditional fossil fuel power plants, though their environmental impact varies depending on factors such as dam construction and waterway alteration. Let's look at hydroelectric power processes, as these processes refer to the overall methods of generating electricity from flowing water. The different types of hydroelectric processes are dam-based, run-of-river systems, pumped storage hydroelectricity, and micro-hydroelectric power systems. Let's look at each process. 1. Dam-based is the most common type of hydroelectric power plant that uses a dam to create a reservoir. Water is stored in this reservoir and then released through turbines to generate electricity. This type of plant is typically used in large rivers with significant water flow. 2. Run-of-river systems do not rely on large reservoirs but use the natural flow of a river to generate electricity. Water is diverted through channels or penstocks to drive turbines. These systems are less disruptive to the environment but produce variable energy depending on river flow. 3. In the pumped storage hydropower process, excess electricity is used to pump water from a lower reservoir to an upper reservoir during low-demand periods. During high-demand periods, the stored water is released back to the lower reservoir through turbines to generate electricity. This system is used for energy storage and grid balancing. 4. Micro-hydroelectric power systems are small-scale systems, typically generating less than 100 kilowatts, designed for local use in rural or off-grid areas. They often utilize small streams and require minimal infrastructure. Now, let's look at hydroelectric dam processes, as these processes involve the operation of a dam to produce electricity. The different types of hydroelectric dam processes are reservoir, penstock, turbine, generator, draft tube, and tail race. Let's look at each hydroelectric dam process. 1. In the reservoir process, the reservoir stores water, which provides potential energy by maintaining water at a higher elevation. 2. In the penstock process, a large pipe directs water from the reservoir to the turbine chamber. The water's pressure and flow forcefully strike the turbine blades. 3. In the turbine process, the turbine converts the kinetic energy of falling water into mechanical energy. A shaft connects the turbine to a generator, where the spinning action generates electricity. 4. In the generator process, the generator produces electricity using the mechanical energy transferred from the turbine. Magnets and coils within the generator interact to generate an electric current. 5. In the draft tube and tail race process, the draft tube, which is a large pipe that guides water downward after it has passed through and spun the turbine, channels the used water from the turbine to the tail race, which is an area where this water is finally released back into the river, where it re-enters the river downstream. Let's now look at the pros and cons of hydroelectric energy. 1. The pro is that hydroelectric energy is a renewable source, as the water used for generation is not depleted in the process. The con is that hydroelectric plants come with significant upfront costs for construction. 2. The pro is that hydroelectric energy is considered clean energy because it does not directly emit greenhouse gases like carbon dioxide during the generation process. The con is that although it is clean, a dam failure could cause devastating destruction downstream, leading to environmental impacts. 3. The pro is that hydroelectric energy is produced during low wind or solar production. The con is that dams require specific geographic and hydrological conditions, limiting potential locations. 4. The pro is that hydroelectric energy can increase or decrease energy output based on demand. The con is that droughts can lower water flow, reducing hydroelectric output. 5. The pro is that in hydroelectric energy there are low maintenance costs after construction. The con is that projects may displace local populations, causing hardship. 6. The pro is that facilities can last over a century with minimal upkeep. The con is that dams could be targeted for destruction, requiring costly security measures. 7. The pro is that hydroelectric energy provides irrigation, flood control, and recreational opportunities. The con is that dam construction can disrupt aquatic life and habitats, sometimes leading to the extinction of species. 8. The pro is that hydroelectric energy does not pose the toxic risks associated with nuclear energy. The con is that lower oxygen levels downstream can harm habitats, requiring artificial aeration to mitigate damage. 9. The pro is that dams store excess water for later use and regulate floods. The con is that dam construction can damage native lands, wildlife habitats, and local ecosystems. Let's look at how hydroelectric energy influences BEV manufacturing. Hydroelectric energy provides a renewable, clean, and reliable electricity supply that can power EV manufacturing facilities. This reduces the carbon footprint of EV production, aligning with the overall goal of producing environmentally sustainable vehicles. The pumped storage hydroelectricity system allows energy storage and release during peak demand. This is crucial in EV manufacturing, where production lines and robotics may require consistent high-demand power, especially during surge periods. Hydroelectric power contributes significantly to the renewable energy mix that supplies electricity to EV charging stations. Using hydroelectricity for both manufacturing and charging supports a green energy loop from production to end use. By powering upstream supply chain operations, such as raw material processing or battery component production with hydroelectricity, manufacturers can minimize fossil fuel reliance, reinforcing the eco-benefits of EVs from a life cycle perspective. Large-scale hydroelectric plants are often located near rivers or reservoirs, influencing the geographical planning of EV factories. Manufacturers may choose to set up facilities near hydro plants to take advantage of low-cost, sustainable power. Let us now look at our lesson summary on hydroelectric energy. Hydroelectric energy is electricity generated by harnessing the power of flowing water through turbines in dams or rivers. Hydroelectric plants use dams to store water and then release it through turbines to generate electricity. There are different types of hydroelectric processes, including dam-based systems, run-of-river systems, pumped storage, and micro-hydroelectric power systems, each offering varying benefits and environmental impacts. The key processes in a hydroelectric dam include the reservoir, penstock, turbines, generators, and draft tubes and tail races. The pros of hydroelectric energy include being renewable, clean, and adaptable to demand, while its cons include high upfront costs, environmental disruption, and vulnerability to droughts or dam failures. Hydroelectric energy supports BEV manufacturing by providing clean, reliable, and sustainable electricity that reduces the industry's carbon footprint, stabilizes energy supply, and powers both production and charging infrastructure. Thank you.